Hello everyone. In this video, we will talk about the hybridization of chlorine atom in chlorate ion. In a previous video, we spoke about the Lewis structure of chlorate ion and why the structures shown here are most stable is explained in a previous video. Link is given in the description. Now, we already know that chlorate ion belongs to the expanded octet category. That means that it can accept more than 8 electrons around chlorine. In this case, we are having 12 electrons. Now, in the ground electronic state, the electronic configuration of chlorine is neon and then 3s2, 3p5. However, in the excited electronic state, two of the electrons from the 3p orbital will jump to the 3d orbital. And that's how we get 2 pi bonds. Basically, these two electrons would be making an interaction with the p orbital of oxygen atom, and that's how we get 2 pi bonds in the chlorate ion. So basically we have 3 sigma bonds and 2 pi bonds in chlorate ion. Keep it in mind that the steric number for chlorate is still 4. While we count steric number, we have to account only the sigma bonds and the lone pairs present in the central atom. So in this case, we have 3 sigma bonds and 1 lone pair in the central chlorine atom. So therefore, the steric number is 4. So that means that the hybridization has to be sp3. So these 3s2 and 3p orbitals will mix together and form 4 equivalent sp3 hybrids. So let us first write the 4 equivalent sp3 hybrids. So we will be having 4 equivalent sp3 hybrids and we will be having 5 electrons in that. So let me draw the sp3 hybrid. So we are having 1 lone pair here and then 1 electron here, 1 electron here, 1 electron here. Now, for the oxygen atom, the electronic configuration is not going to change. It is going to remain 1s2, 2s2, 2p4. So 1s2 orbital doesn't contribute in bonding, so we don't have to worry about that. So we are having 4 electrons in 2p4. So this contributes to 1 lone pair and this contributes to another lone pair, and that's how we get the lone pair on oxygen. How about this electron? Let's say this is 2py. Then that makes a sigma bond with the sp3 hybrid. So likewise, we can get 3 sigma bonds, the chlorine oxygen bond. Now, how about this electron? Because this contributes to sigma. How about this electron? So this electron can make the pi bond, isn't it? So let's say we have orbital like this and then we have d orbitals. So let's say we have a d orbital like this. So it can make a lateral overlap and contribute to the pi bond. Likewise, we can have another d orbital that can make an overlap with this p orbital and make a pi bond. So that's how we got 3 sigma bonds and 2 pi bonds. Now, how about the central oxygen atom? The central oxygen atom has 3 lone pairs, isn't it? So we still have 1 free electron there. And for the negative charge, we have to assume 1 free electron. That's how we are getting 3 lone pairs here. So in the other cases, we are having 2 lone pairs for the end oxygen atoms. But for the central oxygen atom, we are having 3 lone pairs. So depending upon how you write the resonance structure, we can change this. So this is how the hybridization is for the chlorine atom in chlorate ion. And by the way, keep it in mind that because of the lone pair bond pair repulsion, we will not have the ideal bond angle of 109 degree 28 minutes even though the hybridization is sp3, because we have one lone pair on top of chlorine, and then that lone pair can have repulsion with the bond pairs. We have 3 sigma bonds. The electronic geometry is tetrahedral. However, the molecular geometry won't be tetrahedral. It will be trigonal pyramidal because of the lone pair bond pair repulsion. That's all about the hybridization of chlorine in chlorate ion.